welcome to Physical Science in the AM. I'm your host, Joel Shadell. And we took some time to finish up some assignments for hand-in. We're going to just start this up together, relative mass and the mole. We've got this chart in front of us, right? We're going to just take a look at our periodic tables. I got mine pulled down. We're going to talk about what it represents here. Just a second here. So from now on, I do want you to make sure you have calculators that aren't your phone, stuff like that. And on your periodic tables, you guys talk in grade 9 or grade 10 about the numbers. So let's just take a look at, well, carbon, for example. I'm going to draw on here because for the video you can't see the what I'm pointing out. If you look up carbon, and I will erase this, it's not notes. On our periodic table, we have a 6 here, and then underneath we have a 12.011. On that, you guys talk about number 16, the atomic number, it's the number of protons. You guys talk about the 1201, the decimal numbers? There's a mass. If you had one atom of carbon, it would weigh 12, I'll just use whole numbers, 12 atomic units, atomic mass. Okay? So we don't have scales that measure atomic mass in the lab, but that's why we have it on a chart. Now, we're going to use whole numbers to fill in this. So the mass of one carbon atom, number of atoms, I'm doing this. And then we're going to fill it in all the way through, right? All the way. So I've already done the first one with you, but let's do it. 12. We're just going to use whole numbers. And I'm going to put AU for atomic units. Now, look up hydrogen. What's the mass of one atom? 1 atomic unit. Oxygen, rounded properly. What's the mass of 116? This is pretty easy, but I'm getting you used to it. And then sulfur is right underneath that. We're going to use 32 for sulfur. Now, if you want to use a calculator, go ahead, but we'll do this together. But if I had 2 carbon atoms, 2 hydrogens, 2 oxygens, 2 sulfurs, we've got a mass of 24. So this is pretty simple. I'm going to leave a little space underneath here. You can choose to do that too, but if you're paying attention, you might. So obviously 2 hydrogens, I don't have to look these up because that's the mass of 1, so 2 would be 2 AU. Right above the mass of 1 oxygen atom is 16, so 2 would be 32 atomic units. Sulfur doubles that, 64 atomic units. Now, here's what I want to, here's why I'm not the space. I'm going to do it in this again. The ratio is still a 12 to 1 ratio. So you guys follow that? 2 to 24 is the same as 1 to 12. And I'm going to compare to hydrogen because it's a 1. Would you agree that a 2 to 32 ratio is a 1 to 16 ratio, just like, and likewise, comparing that, so 2 to 64 is still a 1 to 32 ratio. Good point. Now, I'm doing easy math, but it doesn't matter if I have 10. If I have 10 carbons, 10 times 12 is 120. So I'm going to write that atomic units. This is 10 atomic units. 10 times 16, that's 160 atomic units. 320 atomic units. Once again, these ratios of 10 to 120 is a 1 to 12, 1 to 16, or 1 to 32 ratio. Units, I missed it. That's why. Everything has to be just perfect. Okay. Now, don't write this part down, but I'm going to erase this. So for a second here, I'm just going to say, I don't know how many. But if I took, then I'm just going to say, so if I put down, don't write this down, but 660 atomic units, how would I find out for the same number of atoms, how many hydrogen atoms? What would you do mathematically? You divide it by 12, right? I mean, it'd be a 12 to 1 ratio, would turn out to be 55. You actually don't have to count the atoms. You know it's in a 12 to 1 ratio, right? Okay. It's sort of like I don't know if you've ever bought bulk nails at a hardware store. Not all of you are like that. You actually, if you buy nails, you don't count out. If you buy nails bulk, sometimes they're in a 3-pound pack. If you go to a hardware store, have you ever seen a scoop? And you just pour the nails into a bag and then they weigh them, right? They don't charge you one nail. They just weigh them in whatever grams or pounds. And they just give you a price per pound instead of a price per nail. Well, it's sort of like that with the periodic table because we don't have scales that measure atomic units. But I have this right underneath here in bold. The mole is defined as the number of carbon-12 atoms to make exactly 12 grams of carbon. So we're going to put this down. This is going to go down. 12, now G for grams. Because grams are something we do measure in glass. But it's useful. Atomic units aren't really that useful. Okay. I don't need to know how many atoms there are. There's actually 6.02 times 10 to the 20. It's a huge number. But I don't actually need to count the atoms, just like you don't need to count nails if you're buying them in bulk. Or in bulk buying, you buy Smarties or something like that, right? You don't count out 1, 2, 3, 4, 5 Smarties. You just take a scoop and measure it, buy them by grams, right? Okay. Well, the same thing here. So if I say 1 mole, that's some big number, and I really don't care what the number is. What I do care, though, is if I want the same amount of carbon that I have hydrogen, I know that carbon weighs 12 times more, don't I? So if I want the same number of hydrogen, I just weigh 1 gram. It's a 1 to 12 ratio. Does that make sense? 1 gram. Everything else above it was in a 1 to 12 ratio, right? I'm going to compare it from now on to hydrogen, even though the mole is defined as carbon 12 grams. But if I want the exact same, I have a reaction. I need as many atoms of hydrogen as oxygen. What's the ratio of hydrogen to oxygen? 1 hydrogen to 1 oxygen mass? 1 to 16. So if I weigh 1 gram of hydrogen and I weigh 16 grams of oxygen, I know I've got the same amount. I don't really care what the number is. No. It is the same. So if I want the exact same amount of sulfur as 32. So this tells me that the periodic table, they were smart when they designed these things. The mass of one atom was designed in atomic units so that you have something we call a mole. You don't have to convert, it's the same amount in grams. So we can use it as individual atoms, atomic units, or practical weight measurements in grams. And you use the same numbers. It's not witchcraft that it's the same, it's by design. Now, in the video, I'm going to show you a video, but it won't show up properly. So I'm going to just start it. And here, I'll pause this video for a second. I'll let the ad go. Okay, if you're watching on video, Google up the truth behind off-nautilus number and watch this. We are going to watch about